Okay, this is 2.1 Part C. Now this is the last video for 2.1, and we're going to be talking about one-sided limits and a very special limit. It says one of the reasons a limit does not exist is because the function approached a different value from the left than it did from the right. Suppose we have the graph below. If you notice, the limit as x approaches c from the right is headed to k. Not from the right. I'm so sorry, that's from the left. I'll probably just confuse the heck out of you. Sorry about that. From the left is k. And then the limit as x approaches c from the right is going to L. Because these aren't the same, then the limit as x approaches c does not exist. It says we say that the limit of a function as x approaches any number c exists if and only if the limit as x approaches c from the right is equal to the limit as x approaches c from the left. Using limit notation, we have that they have to be the same. And if you could see me, here's one arm, okay, with a finger pointing. Here's another arm with the finger pointing. Here's me. There's my arms. Okay. Yeah, I know they're coming out of my head. Pretend they're not, okay? Okay, they have to be headed in the same direction. Limit from the left has to equal the limit from the right. This is good. This is good, okay? These are my fingers. Whoops. That's good too. You can have that. This is bad. They can't be going to 2 different spots. They're headed to the same place. They're headed to the same place with a hole. All those are fine. But if you're going to 2 different spaces, it's no good. The limit does not exist. Okay, it says let f of x equal 5 minus 2x as x is greater than 2 and 3x plus 1 as x is less than or equal to 2. This is a piecewise function. It splits at 2. So this is my invisible dotted line. It's not really there. I've got 5 minus 2x to the right of 2, and I've got 3x plus 1 to the left of 2. M is 3, b is 1, m is negative 2, b is 5. Okay, so I'm going to start out. I'll graph this one, the 5 minus 2x. No, I'm going to graph the 3x plus 1 first. I'm going to begin at 1. Okay. And I'm going to go up 3 over 1. Up 3, 1, 2, 3 over 1. So it would actually hit here-ish. That's probably not straight. Let's see. No, that's not. Let's just go ahead and draw the line. Be about right there. Okay. And then 5 minus 2x, it begins at 5. 1, 2, 3, 4, 5. This is my invisible first dot. It goes down 2 over 1, down 2 over 1. It's going to start here. Down 2 over 1, down 2 over 1, down 2 over 1. Oops. Pretend that's straight. Okay. It says graph f of x. Well, I've done that. Find the limit as x approaches 2 from the right. As x approaches 2 from the right is going to come from this direction, okay, and it looks like it's headed toward 1 because it's wanting the y value on your y-axis. The limit as x approaches 2 from the left is going to be coming from the left, and it's headed toward 1, 2, 3, 4, 5, 6, 7. What can you say about the limit as x approaches 2? The limit as x approaches 2 does not exist. Now you could have done this question without drawing it. If you had looked, the limit as x approaches 2 from the right. Well, I'm going to be on the right side of 2, so I'm going to be greater than 2. I could have plugged the 2 in right there. 5 minus 2 times 2 would have given me 1. If I want the limit as x approaches 2 from the left, that's going to be on the left side of 2, so that's going to be this one. you'd do 3 times 2 plus 1, and that gives me 7. You could have done it without the graph. Okay. It says investigate the limit as x approaches 0 of sine of x over x by sketching a graph and making a table. Well, we're just going to graph it. Graphing it. And it's going to be sine of x over x. Okay, and we can look at it and tell where is it going. As it goes to 0, it's headed toward 1. Now we could zoom in. If I zoom in far enough, there's going to be a hole in my graph. But you can tell if I trace. And look at my trace points here. See the y value? As I'm headed towards 0. At 0 it's undefined, but to the left of 0 it's 1, to the right of 0 it's 1, and it's pretty much 1 for a pretty good ways. Okay, you can kind of tell it's going to 1. It is headed to 1. Okay. This is going to be if you plug the limit as x approaches 0 in, sine of 0 over 0, sine of 0 is 0 over 0, so it is a do something else situation. The do something else that we're going to learn is after we do derivatives. So right now you just need to memorize that the limit as x approaches 0 of sine of x over x equals 1. That is one that comes up a good bit. Now that actually applies to anything. If these three things are the same, like this takes the place of my x, if the limit of smiley face goes to 0, of sine of smiley face over smiley face is still 1. The limit as I am getting a phone call. No, I'm not. I'm just kidding. The limit as a goes to 0 of sine of a over a, also 1. As long as these three things match, it's going to go to 1. Now this one, I'm trying to decide if I want to show you the work here. Nah. Just trust me. If you add in this 5/4 right here, you can kind of pull it out a little bit. This is not really a rule, but this is not the algebraically how you should do this, but it ends up being the same as this. There's several steps that you would go through in the meantime. Do I want to yeah, shoot, may as well. Fine. I'll just show you how it works. What you would do is if you multiply the top and bottom by 5, just go with it. This piece is the same as doing this. Okay, this is 1. So it's just 5/4. Or you could have just said, ooh, it's 5/4 and been done, which would have been wonderful. On C, so let me do one more like that. What if it's sine of 3x over 7x? It'd just be 3/7. And on the third one, you got to do a little bit of algebra here. X approaches 0. If I did sine of x, if I pull out an x and have 5x plus 1, this piece is 1. So it'd be 1 times 1 over 5 times 0 plus 1, which is 1 over 1, which is 1. And that's the end of that. I totally could. We're not going to do the sandwich theorem. That's not in our AB syllabus. The end.